Okay, so today what we'll learn NumPy arrays. So basically NumPy is a Python library that is used to work with arrays and single dimension arrays, multi-dimension arrays, and they are very important because they ease us in calculations and the arithmetic operations in different libraries that we learn so far. So other libraries that work hand in hand with NumPy, we have got pandas, the panel data library that we will use to work around with different data sets. Then we also have SciPy. So SciPy is very used in scientific research and also as well as in engineering to solve mathematical problems. So to work in those libraries faster and easier, you are going to use NumPy, which is a backbone for all the libraries. And the important part is NumPy is made from C. So C is the fastest language, programming language in the world, and it's used in different machines, devices. So to build NumPy from C, it means we'll have fast calculations in our program. So I believe we already installed NumPy from the past classes. So I'll just demonstrate on how we're going to use NumPy and then NumPy crash course. So this is not a full training on how different methods of NumPy, but they will get you up and running, and they are relevant for this course. So first of all, we'll go to our first cell and import our package NumPy as np, and press Shift Enter to execute the code. So as you already said, that NumPy works with arrays. So we do have to create NumPy arrays. So there are different ways how you can do that. But the first step how you can do that is changing a list to a NumPy array. So let me just put a comment here. Creating a NumPy array from a list. And first of all, we have to create a list. So let me put a variable name here called my list, and a simple list with elements 1, 2, and 3. Let us execute that one. So we are good to go. There are no errors. And let us create our NumPy array from the list. So in order to do so, we need to create a variable called the R, which stands for array. Then we'll write just like this, np. Remember, we have imported our NumPy package as np. So we'll reference it using np keyword. So we write np dot. So when you click dot, dot is an operator that you use to access methods that are in NumPy package. So when we say dot, we say array. There is a method in NumPy. Then that method is like a function, and then inside the function it requires a parameter of a list. So we can just say my list. Then click Shift Enter. So what you have done here, you have created a NumPy array from the list and put it in the array variable. So if we say array, you can see that there is an array as our output, just like that. So you can create different arrays from NumPy, from this method called array from NumPy. Now, the powerful thing about NumPy, it can also create matrices. So we do know matrices from maybe numerical methods classes. So matrices are the dimension arrays that you can use. And you can say, what's the important thing of creating these matrices? We'll see that later on as we are creating maybe image detection system. The machine doesn't understand the images, but it can understand color codes, which are in numbers. And every image is a multi-dimensional array. So in order to get the colors, you can get the multi-dimensional array. And if you want to prove this, you can actually appreciate that even Photoshop has got this color space called the RGB. It uses numbers, so it's just like that as well. So we can also create a dimensional array from a matrix list. So we can just say matrix, my matrix is equal to, and create a dimensional array. Let's say 1, not like this, but here, 1, 2, and 3, and separated with a comma, say 4, 5, and 6, and continue with the other one, 7, 8, and 9. So this is a list, but it's a list with a nested list. So in order to create a dimensional array, what we need to do is to create another variable, and in that variable we need to convert this array in this list into an array. So we can just say np.array and put the name of our list. So it's our matrix, and click Shift Enter. So in order to check our matrix, we just need to call the variable name, and just like this, and you can appreciate the outlook of our list, that it's looking like a matrix in real life. So that's how you can create a dimensional array. Now we want something else to be done. We want to ease our code. We need to create these arrays as fast as possible. So in order to do so, Numpy has got a method that is you in creating these arrays. So the method comes like this. We call the reference to our Numpy package np.arrange, and you put the parameters just like this. So the parameters are going to be the starting point of your array and the ending point -1. So it's like, maybe if we are starting from 0 to 10, the numbers are going to be, also we separated by comma. So the numbers are going to start from 0 and they are going to end from 9. So it's 10 minus 1. So if we click Shift Enter, you can appreciate that the array starts from 0 and ending up at 9. That's how you can create the Numpy arrays. Now, in good practice, you don't have to create just like this. You need to assign to a variable. So we can just say my new underscore array, and is equal to like this, and invoke your array, call your array here. And once you do this, you can see that you have assigned it to a variable just for a good measure. Now this array, these parameters doesn't end like right here. Maybe you want to modify the arrays, the contents of the array. What you need to do, let me just create another variable name here, new underscore array, maybe 2, and is equal to np.arrange. So remember that we had a range function in Python that also do the same, but that one create a list. In this case, it's creating a Numpy array. So we say arrange, then we have our starting point. Then let us put 11 here because we want to end up at 10. Then we want to have a step. We want to jump a number. So we can place here 2. So we will be jumping every number at a position number 2. So if we click Shift Enter here, we have kept our array in the my new array 2. Then let us call my new array 2. Click Shift Enter, and you can be able to appreciate that we have jumped the second values after we have called an element. So we have said from 0, let us jump the second value and go to 2. So 2, you jump another. So these are steps. They are steps that you will jump. in creating your arrays. So Numpy has got also some cool features to create fancy arrays that you can use in your calculation. So if you have ever taken a class called maybe numerical classes, numerical methods classes, you can appreciate this function in solving your problems. So for example, you can say NP zeros, and you put a bracket, say 4. So what you are creating is an array with the 4 elements, four elements. So if we say shift enter here, you can see that I've created a 0 array with 4 elements. Now you're saying I want to create it as a matrix, as a multi-dimensional array or 2-dimensional array. What you need to do is to say np.zeros, and here, but inside you need to put a tuple. You don't put numbers like 2 and 4 just like this. You need to put a tuple, because if we say like this, you can see there is an error because it does not interpret like this. You need to put a tuple, and a tuple is an element with round brackets just like this, which are immutable, if you can remember the previous classes. If we press shift enter, you can see we have created an array with the 2 rows. So these are rows and 3 columns, just like this. You can create fast matrices in Numpy. But however, maybe you want to create also an array with ones. You can say np.1 ones and put the elements inside a tuple. You can just say maybe a 4 by 5 by 6. So it's faster because you can create bigger matrices with a small line of code. And as you can see, appreciate these matrices with ones as element. And it's, as the way we calculate it, it has got 4 rows and 6 columns. So you can see there are 4 rows here and 6 columns, as you can count it. But however, there is something else that you can actually do in creating arrays. For example, maybe you want to have array, maybe a range of values, but you want to be in a certain range. For example, if we say we want to have numbers from 1 to 10, but the numbers should be 2 million numbers, any possible value that you can get. So in order to do this, what you need to do is to write a function which is in Numpy called np.linspace. So in linspace, we call it as a linear space. Then you put brackets inside, you put a starting value separated by a comma to the ending value. So we want to end at 10, but however, I want to have 200 possible values from this range. Numpy is very intelligent to generate random values that are in this range. So if we click shift enter here, you can see we do have massive numbers. So you can create these values, massive random values. Maybe you are creating maybe a certain algorithm that is able to create to find an optimum value, and you want to multiply it with a certain variable. You can do this in Numpy and generate these values as fast as possible. So there is this matrix, we call it identity matrix in numerical methods, which is very important to calculate different calculations in mathematics. So in order to create this identity matrix in Numpy, there is also a function, we call it np.I. And in this case, what you need to do is to place in the value that you have, that you can create. And you see that an identity matrix is a matrix which has got identical number of rows and number of columns. So maybe we want 6 number of rows and number of columns, and you can appreciate if we created this very fast, and you can see this is an identity matrix. As you can see, the arrangement of ones and zeros, just like that. That's how powerful Numpy is. And there is also a function which you can generate random values, and you can create arrays from it. So let me show you how you can create random values in the same dimension. So there is a different I want to show you here that is very important. So if we say np.random, we want to call the random method, and inside that random method, there are different types of methods that you can also create, that you can use to create random functions. So if we say rand and put here bracket and put 3 and 4, what we are trying to say here is we want to create an array, a multi-dimension array with three rows and 2 columns. But however, there is something unique that you can see here. All these random variables, they are ranging from 0 to 1, and the 1 not included. So meaning to say that these random values, you can use it maybe in probabilities and whatnot in your programs. And also you can also create random values, random integer values. To do so, you can say np.random.randint and put parameters inside. So these parameters, they are very easy to understand. The first parameter is the starting point of generating your random value. So let's say 1. The second parameter is the maximum number. So this maximum number is exclusive, meaning to say if we put 100 here, it's saying that 100, it will not be included inside the array if you generate random variables. And the last part, you put the number of values that you want to generate. So for example, if we put 5 here, 1 may be included, but 100 is not included, but we want 5 values. So if we press Shift Enter here, you can see Numpy has generated 5 values: 68, 8, 72, 5, and 66. So these are random values. If we go here and click Shift Enter again, you can see it's still generating random integers and creating an array from it. So these are very important in coming up with different calculations in maybe statistics and whatnot. Now, there is also another function of generating random values. So if we press np random.rand n here, if we go here and click Shift Enter tab, you can see that it uses a standard normal distribution. So you can get this component by pressing Shift and Enter. So this random distribution is very important, because what you do is you don't have the ranges from 0 to 1, but this range can it can segregate in a normal explanation. It can segregate from 0 to other values, but it gets closer to 1. So you can have 1, negative 1s, and whatnot when you are generating this code. So this is very important when you are generating graphs and whatnot in your calculation. So for example, if we put np.random.randn and place maybe 5, what we are trying to say, we are generating 5 values, but in the standard distribution. So if we press Shift Enter here, you can see these values, they are getting closer to 0, but they are not going over 2 and other values. You can check that you can Google that maybe in distributions in other sources like Google and whatnot to understand what is standard normal distribution. And however, we can also spice things up. In this case, maybe we want to generate a multi-dimension array. We can just press np.random.randn and put maybe 4, or maybe we want to put 5 and up to maybe 9. We wanted to have this array, so it's a big array, so it's a multi-dimensional array with 5 rows and 9 columns, if you can calculate it properly, because it cannot fit in my screen. So that's how you can actually generate these functions as well. Now we also let me just show you something that you can use to create maybe a random function a random function. There's a certain method that you can use to create maybe not a random function, but a dimension array. So for example, if we create a new array here, but this new array, we want to create it in a single dimension array. So we can just say maybe right here we put 25, just like this. Let us check our array. Yes, it's a single dimension array, but maybe you want to change that array. You want to change that array. There is a function inside inside NumPy. We call it reshape. So if we go here and say array new dot reshape, inside that reshape method, what we want to do is to put the arrangement of our matrices. So let me show you something. If we put here 5 by 4 and click Shift Enter, you're going to see that there is an error that says an object has no attribute reshape. What does it mean by this? It means that our single dimension array, it cannot generate a 5 by 4 matrix, because there will be other elements that will be left out. So in order to do that, you need to generate a 5 by 5 matrix. And okay, it's saying it does not have a reshape function. Let me run here. And underscore new dot reshape. All right, there was an error, a typo. You can see I read reshape, not reshape. So let's go back to 5 by 4, and you can see that there is an error code cannot reshape array of size 25 into shape 5 by 4, meaning to say this function here requires an array and requires a parameters that can fit all values in this array. So in this case, let us just slide 5 by 5, and you can see that it's able to reshape our single dimension array to multi-dimension array and create 5 rows and 5 columns. That's how you can use the reshape function. And however, NumPy has got also it also has got other function methods that is our work. You can find the maximum value and the minimum value. So if we say r new dot max, click Shift Enter here, you can see that the maximum value here is 24 as shown here, and you can also check the minimum value. And here you can see the minimum value is 4, and you can also use it to find where that value is located. So if we say array underscore new dot arg max, so we want to find the argument max, the position where the maximum value is located, and you can see that it's on index number 24. So if we go here and say array underscore new dot arg min, and so we want arg min, you can see that it's on index number 1. So this is what you're seeing. They are indexes, they are not the actual value inside it. And to check, maybe you also want to check the shape of your array, you can just say array underscore new dot shape, just like this. And you can appreciate that we have not actually we haven't actually put open and closing brackets here because it's a self-invoking function. But there is something that I want you to check around. You can see that this array.reshape, it did not create a new array. That's why we are able to access this array as a single dimension array. So in order to do this, you need to assign it to a new variable. But however, there is a problem, and we'll see that later on in this course. Now, let's see something else here, continue with cool functions that are variable. Now, let's see something as saying we want to check the data type of our components in this array. So if we say array underscore new, and let's say dot data type, you like this. In order to check the preview of the components, you can just say shift enter. You can see that we do have 32-bit integers in our array. So that's how you can check. Maybe kunchito one you're working somewhere else, akupatsa data yambiri mbiri, but you want to check the data type of that data set omwe akupatsayo. Use the d type and check the data type that you're working with. So there is what we call indexing, and there is what we call indexing and selection in Numpy arrays. So indexing and selection Numpy arrays is the same as what we are doing with a list. So let me just create another array here. So just say my new array is equal to np.arrange maybe 0 up to 11, just like this. And let us check my new array. Values again, you can see that the values are what we're expecting, 0 up to 10. Now, maybe we want to grab something here. This is a very important situation that you can meet out there, and it's also asked in different interviews when you are applying for a data science position. So if we say we want to grab maybe number 8 here, what we do, we can use the index notation. So we can just say my new underscore array bracket. We are indexing. So we put the 8 index and click shift enter, and we can be able to say that you have grabbed the 8th value here that you have got. So we are going to the index number 8, and you're able to grab the value right here. So as this is called indexing because you start from 0 up to 8. Remember, Python is a 0 language. So we can say 0, 1, 2, 3 up to 8. That's why we are able to grab 8 here. And you can use you can have selection using slicing notation. So let's say selection using slicing notation. So in this case, for example, we want to grab particular elements in our array. What we need to do is to write my new underscore array and put a bracket, and we want to slice, meaning to say we want to grab elements. So the first element that you put in the bracket is the starting point of your slicing. So for example, we want to slide at index 1 and end maybe at index number 5. But in order to end at index number 5, you are going to put 6, because the way we counted 6 minus 1, which is called 5. So you put 6 here because 6 is not included, it's exclusive. So if we click shift enter, you can see that we have started from index number 1 and end at index number 5 from our array. That's how you can get those values inside using slicing notation. So there are cool ways you can do slicing notation. For example, if we say my, let me just show you something. My underscore new underscore array. If we put 0 up to 6 here, you can see we are starting from 0 up to 6, but there is a short form of writing this syntax. For example, if we say my new array, just like this, we can neglect the 0, but by just putting the colon and 6, we still have the same result. So this notation here is the same as this, but this one is very important if you do not know the end of your array. So it's important if we say maybe my new array, just like this. So we want to start from index 1, but maybe we do not know the end of our array. So we don't have to hustle and to check the last index and whatnot. What we need to do is to put 1 and the list. We'll see this how we can use this notation when we are dividing our data set when working with machine learning models, because you cannot know when your data as the end of your data set. We can work with maybe 60 million data points, so you can't calculate all those points. What we need to do is to slice the data. So if we press like this, you can see that it has gone to the end. That's how you can use slice notation when you are indexing your values. Now, there is what we call broadcasting. Broadcasting in Numpy array. So what is broadcasting? So broadcasting is a way that you use to change the values inside your arrays. So how can we do that? It's the same as reassigning values in list. So let us create a new array. So let's say my other underscore array, and let's say np.arrange, and let's go from 0 to maybe 13, and quick shift enter. Let's check if our array is generated just like this. Now, if we want to broadcast our array, what we can do is this. We need to put the name of our array. So let's say my other array underscore array, and use slice notation to select the values that we want to manipulate. So I want to start from 0 up to the index number 5, and let's say I want to change that those values to 100. If we do just like this, we are going to change the values. Now, if we go and check the array again, and you can see that we have changed the values. What we have done, we have manipulated the values just like this. This is called broadcasting. So for example, maybe you're working with a data set, values you can put default values by just broadcasting the values right here. But however, there is a mistake. Why? Because it has changed our original array. Now, let's say we want to have a way around to still keep our original array. So Numpy does this so that it preserves memory in your system. It can't just be creating new arrays one way or another, because you are going to overload your system and your resources and you can see that if you are creating new arrays, ngati lamwawali ochepa inside your PC iyamba wanga drag and system yako ikhala slow. So Numpy does this because you remember it's fast computation, so it makes sure that it reduces these complexities. Now let us reload our array from here, and let us comment this section. So if we reload our array, it means we do still have our array. We have went back to the original array. So in order to deal with this, what we need to do is something. But first of all, let me show you something. Let's say we want to have sliced array. So we want to keep something here, maybe data, a certain type of values from our original array. say my other underscore array, and put the values from the beginning up to 5, just like this. So if we put sliced array, we have actually taken values from the original array. But however, if we broadcast these, so if we say sliced an array, and I want to take all the values, so if you want to take all the values, just do like this. See how powerful it is. So if we say 100 and go to sliced array, as this, you can see it has changed the values. But however, if we go to my other array, you can see that it has changed, and we want to fix that. We are continuing with our lesson, and we said, we want to fix this problem. There is instead of the copy copy about our function kuipanga broadcast here. Copy, as a normal understanding, we were supposed to change only this copy, but it's still changing the elements from our original array. So we said that Numpy does this in order to keep your memory in check, because this is just for the lesson's sake, but you in real life, you can work maybe with 6 billion data points. So you can't just be creating new arrays from those data points. What you need to do is to use the same array and manipulate it. But however, we don't want to do that when we have just selected a couple of elements inside our array. So let us actually revert back to our new to our original array. So if we go here and create this array, and we don't need to broadcast it here. So if we call our array just like this, we can see we have reverted back to our original array. So in order to do this, you need to copy the original array, or you need to copy the sliced array. So Numpy also has got a copy method. So if we say my other copy, just like this, we can just say is equal to my underscore other array dot copy. It's as simple as that. So if you press Shift Enter here, you can appreciate that the code has executed without errors. And if we check the copy array, you can see that there are no errors. So you can also play around with this, with the sliced array, and copy it to another array. So if we can change everything in this array without affecting our original array. So that's how you can create a copy of your functions in Numpy. So let's go to selection, a typical use case selection in our 2D arrays. So if we are playing around with the 2-dimensional arrays, maybe we want to select them. So there are 2 types of selection in this Numpy array. So first of all, let us create a 2D array. First of all, let us create maybe 2-dimension array. So in order to create a 2-dimensional array, I just maybe mention array underscore 2D. And what we need to do is to explicitly Okay, let me just say np dot arrange. I don't have to create maybe arrays from scratch. I'll use the methods just like this. So let me just say from 0 to maybe 19. And I want to reshape that array. Underscore 2d dot reshape to, okay, so I want from 0 maybe to 25. Let me just say 25 elements here so that we should not have 100. And maybe I do want to have 10 by 10 matrix, size into 10. Okay, 10 by 10 matrix. So you can see that I have created a dimension matrix with just 2 lines of code. That's very powerful. If we were using REST functions, we could have taken a lot of time to create these elements. So we want to select, we select values in a 2-dimensional matrix. First of all, you can use a bracket notation. So a bracket notation. So in this bracket notation, what I can say is array underscore 2d. And what I can do is maybe I want to select, maybe I want to select 7, 8, 9, 17, 18, 19. I want to select those values. So that's the power of bracket notation in NumPy, to select those values. So in order to do so, what I need to do is to put, okay, first of all, before we go there, what I can say, maybe I want to select, I want to select the first column here, the first row. So I can just say from this code, let me say I'll put a bracket, then the index, which is 0, because number is 0. It will start counting from here, from the low. So that is the 0 row. So if I execute this, you can see that, all right. It's counting from 0. All right. Let me create another dimension. Let me create another dimension of array. Let me put it as 3 by 3 because it's counting from the first component. That's why we're having different notations here. So let me put maybe another dimension of matrices. So let me say array underscore maybe 3d, and put here np dot array and bracket. Let me just create a simple dimension array, maybe from 1, 2, and 3, 4, 5, and 6, and let's put here 7, 8, 9. Right, I did not close with another bracket here. Need to close another one here. Yeah, we are good to go. So if I check array 3D, let's go 3D, you can see that I'm working with a dimension array, a dimension array. And if I say, for example, I want maybe to pinpoint maybe 5, because we're using a bracket notation. But however, a bracket notation, what it does, it's getting a fixed value. That's what bracket notation does. It doesn't select or slice that component. That's why we were getting 0 here, because if we go here and say 1 from 0, we are getting a value from starting point from 0 here. But however, that's not how we calculate bracket notation, because if we go here and say 0, it's not calculating. Like, there are no scalars that are found here. So it's treating this as a single dimension matrix. That's why we have actually moved out from this example. But however, this example, because we have explicitly mentioned that this is a 2D array, so what we need to do is we can call the array 3D just like this, and we need to call, maybe we want to call 5 right here. So if we place again, like maybe 0, you can see that it has called the first list or the first array inside the dimension array, still not a single value. But if we will say we want to have a single value, we add another bracket, and maybe we want to grab 2. So in order to grab 2, we can just say here 1 and click Shift Enter, and we have grabbed 2 in this case. So that's how you can use bracket notation. But however, there is also another type of notation. All right, so we have a bracket notation, but in this bracket notation, you can only grab one element. So in order to grab maybe multiple elements or select multiple elements, you use a slice notation when grabbing multiple elements, which is very massive. But however, I just want to show you something here. I just want to show you something that you can use, which is a short form of grabbing single elements, which is very interesting. You can just write array 3D, a bracket, and just write the same way 0 minus, not minus, but comma, separated by comma, and 1, and still you can grab the same element. So you can use this or this one, it depends on your choice. But however, this notation is used in slicing, getting values. So for example, if I write array underscore 3D, I can put a single bracket, but inside that single bracket, I'll actually choose the elements that I want to slice. So for example, if I say I want maybe to grab these elements 5, 6, 8, and 9, what I will do is I will choose. So this actually, you can master this by practicing a lot. Make sure you do practice so that you can master how you can slice these arrays. But it's very important. So if I want to grab 5, 6, 8, and 9, what I will do, I will slice using the same slice notation. So I want to leave out the first array, but I want to grab the last. So to do that, I will say I want to have the ones, the first. I want to start counting from the first index, not from 0, and I want to grab the last, just like this. You separate it by comma. Then once you do that, what we are trying to mean is that the first parameter from this bracket is slicing the number of rows, the rows that are available inside that multi-dimension array. The second element that you put is slicing the columns. So in this case, I want to leave out the first column, which means to say I'll just write 1, and I want to grab the list of the column, so I'll just place here colon. If we click Shift Enter here, you can see that we have grabbed the elements 5, 6, 9, 8, 9, just like this. So make sure you do a little bit of practice in grabbing those elements. Now, there is something important that it's available in Numpy. So we can just say, maybe I can call it Boolean comparison. So what does it mean? It means that we can check certain values inside our arrays. So for example, if we say, let's check if we have an array here. So my other array, we do have my other array, which we can use. So you can just say my other underscore array. Now, if we say that in this array, we want to check, maybe we want to check if the values are greater than 5 inside our array, which is very important concept in data science. So if we want to check if there are values that are greater than 5 here, what you can do is to use this type of arrangement. So I can just say here my other underscore array is the elements greater than 5, just like this. If we click here, shift enter, the result is going to be a new array, but that array contains Boolean values. So you can see there are false, 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 true, 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 true here. So the true part is just showing you that there are values that are greater than 5, but you want to see those values. So the best way, what you need to do is to assign this to a variable. So say array boo, just like this, is equal to that comparison. So you have kept that array, that new array in array boo. Now, in order to get the values, you write my underscore other underscore array, put a bracket, and inside that bracket, you put that variable called array boo. Click shift enter, and you can get the results. So the results are all the numbers that are greater than 5. That's how you can use this, and this is very important. If you are checking if you have 0 values inside your data set, you can use things like this. We'll see that when you go to Python site to pandas. Now let us go to another section. We are about to finish, so let us go to other sections that we can appreciate by the use of Numpy. So Numpy is very interesting because we can have arithmetic operations using Numpy. So for example, we call them array operations. Array operations. So for example, in my underscore other underscore array, I can just say I want to add maybe 1. So if I click shift enter, you can see that the array, the output is an array which is which has got 1, which all the elements have been added with 1. So we had 0, 1, now we had 1 plus 2. So we can also say maybe we want to add the array with another array. So let us use the same array. So if we say my other here underscore r, it's as simple as that. So this array has added by itself. Or maybe we want to multiply this array maybe with the 2. You can see that all the values have actually been multiplied by 2. Or you can actually put raise all the values to square of 2, and you can see that we have done that, and we have actually multiplied, we have actually squared our values. That's how you can work around with all these multiplications. And still more, you can you can actually do division or multiplication or subtraction using this method. But however, I want to show you something which is very important. You can see that the first element that we do have in this array is a 0. And if we say my other underscore other underscore array divided by, that's the sign of division, my underscore other array, and click shift enter, you can see that there's an output. We do have an output, but our output has got a value called none, which is not a number, meaning to say 0 cannot divide by itself, which is called not a number. So you do receive results, but you get a warning from Numpy saying invalid value encountered in true divide. So meaning to say there is a number which doesn't which is not a number in this case. And if we say also 1 divided by my other array, just like this, the output is actually obvious because 0 divided by a number is infinity. And if we shift enter, you also receive a warning. And that warning, you can see divide by 0 encountered in true divide. So you can see that we do have a value called infinite in this case, and the value is infinite because 0 divided by 1 is infinite. So that's how you can have it. And remember, it's still giving you values, not a, if we say, for example, not like this, if we say just like this, you can see that division by error is an error by itself, but in NumPy, it gives you the value because it's numerical operations and we can work out with our operations in this case. So that's how you can do it in NumPy. And NumPy also has got other features that are very important in our calculations, maybe in mathematical calculations. For example, if we say np dot square root, so it's sqrt, which is a method, and inside this method you can put the name of your array, so my other underscore array, and click shift enter, and you can see we have square rooted all the values inside our array. There are lots of them. You can put maybe sine or log, and put the name of your array, just like this. And you can see that there is also an warning because we do have 0, and log of 0 is negative infinity. That's why it's giving you a warning, just like that. So there are lots of these calculations that are available on NumPy. You can Google in order to explore different types of methods that are available in NumPy. So anyway, this is all I had for you in this NumPy crash course, and this is basically what you need in this course. I don't know if there are any questions on this section that we had today. So let's meet each other on the next session that we do have on pandas. So make sure you join that session to learn what pandas are. Then after that, we are good to go to Matplotlib in visualization. Then we'll be done with data science and proceed with machine learning. So thank you very much for a wonderful